Alright, back at it. We got the integral of e to the x cosine x. So this one, it's a little tricky. So we'll see why that is here in a minute. So if we take, doesn't really matter which one you use as a u. So we go, let's just do u is e to the x. dv would be cosine x dx. Because either one, if we take the derivative of these, we're never going to get to 0 or a constant. So du is e to the x dx. We have antiderivative of cosine is sine. Ooh, I really wrote cosine without an x there. Sine x. Plug it into the formula. So we have this integral equal to uv, so e to the x sine x minus the integral of v du. So e to the x sine x dx. So we try to integrate, and we're running into the same problem that we started with. We have e to the x times a trig function. We don't know what to do. So yes, you probably guessed it, we're going to run through another stage of integration by parts. So we're looking at this piece here. So again, we're going to do a u, and we're going to do it e to the x. dv is sine x dx. du would be e to the x dx. And our v is, so antiderivative of sine is negative cosine. So plugging into our formula, so what we have, remember, so if we're doing a second round, I'm going to put this in parentheses. Now, wait to close it. So uv, so e to the x, times v, so negative, so that's a negative cosine x, minus the integral of v du, so we have a negative e to the x dx. Oh, not dx. Negative e to the x cosine x dx. Okay. So everything else on the outside brings down, so we have that negative there, and we have our e to the x sine x. All right, so this isn't tricky because of all these negative signs. It can get a little crazy. So let's clean that up a little bit. We have e to the x sine x. We have to carry this negative through to the inside, so we have a negative negative, so that's positive. So positive e to the x cosine x. We have negative negative in here, so right here that's going to be positive when we pull that negative out, and then we carry the negative in, so it is subtraction of our integral of e to the x cosine x. So now we sit here and we think we're really not getting anywhere. Well, we need to be able to identify that this integral that we just got after 2 rounds of integration by parts is identical to the original problem. So we have to do a key move here. So what we want to do, so this integral right here is on the left side. Sorry, I should have stayed in green. That integral is right here, because we know that all of this has been equal to the original problem. So I have the integral of e to the x cosine x over here, and I have a subtraction of the same integral. So what we're going to do now, we are going to add this integral to both sides of the equation. If I do that, we end up with 2, because I'm adding 2 of these together, I have 2 times the integral of e to the x cosine x. Equals this little chunk here, because I got rid of this because I added to both sides. E to the x sine x plus e to the x cosine x. Now if you really wanted to, you could factor out the e to the x, put it outside parentheses, and then have sine plus cosine on the inside. You don't have to. But now what we want, so we want to know what the original integral is, so all we have to do is divide both sides by 2, and we end up solving the problem. So we have e to the x. I'm going to go ahead and factor it out, just because we can. You don't have to, though. You can write just the right-hand side of the equation like we had it. So e to the x times sine plus cosine all over 2. Now we're done. So it is a little bit lengthy, and the struggle will come in when people fail to identify that we end up with the same integral as the original. But when we do, we would have to add it over and get double the integral, and then divide by 2. So this right here is the final answer to this integration problem. Okay? So I will stop here, post another video on, there is a trick to this, to doing integration by parts. I mean, it's not really a trick. You're doing the same thing. You're taking the derivative and you're finding the antiderivative. But some problems, it can speed the process up a little bit, so you're not writing everything out. I will get that recorded here. So let me know if you have any questions though on this process, and we can go from there, because there are some tricky problems. It's just about repetition and getting the process down and remembering the formula. Like I said, if you're having problems remembering the formula, go through the introduction to this and do the product rule, do derivative of uv, and you can get to the formula that way. So, all right.